Hey everybody, welcome back. Tom, Moto-Resto LLC, working on a TRX 250EX, one of these quad sports. It's a 2005 model that's been sitting for, I don't know, last century or so, and it has your typical fuel system contamination issues. Once I rebuilt the carb and stuck it back on and put fuel to it with this can right here, it started pissing out the overflow / drain. I'm going to show you what caused it. I'm going to show you how I fixed it on this video, so stay tuned. Howdy folks, got a quickie here I'm going to show you. This is a carburetor float bowl from a Honda TRX 250EX or ES or something like that. And unlike a lot of other carburetors, this one has got an overflow standoff in there. So if the float bowl level gets up too high because the float needles failed or the fuel cock failed, it would overflow out the carb instead of going in the motor. And this cracked at the base. I don't know why. Probably vibration and age, because this is a 2005. I've run into this before, mainly on the KZs and things like that, the old ones. As you can see, it cracked way down inside there, right at the base. There's no way to solder that. So normally what I do is I drill these out and put in 1/8 copper tubing. But this interacts with a part of the carburetor body, the top of the carburetor, where it goes through a small hole. That 1/8 probably won't fit, and I could probably get some 1/8 and turn it down, but I don't even have any of that, and I don't feel like going out. So what I do have is I have a brass screw. I don't know, I bought it for something pretty long, quite a bit longer than what I need. Now naturally this has actually got to be a little bit longer, but not by much. And so what I'm going to do is I'm going to turn this down, clean up all the threads, and I'll probably get it close to this diameter, but I'll drill through it first, and then we'll take it from there. I'm going to try to make one essentially. I'm going to make one with a certain letter drill size. That'll be perfect to drill that out, and slightly bigger than the hole that was existing when that was pressed in. And then we'll press one in and fix it. What I'll do first is I'll give it a quick face, choked up in the chuck, and then I'm going to put a center in it just with one of my tiny centers. And we'll put one of the smaller live centers in, dead centers, just to keep this thing a little bit more steady when it's got the kind of stick out, it is brass. And I don't know if I'll be able to get it down to dimension at that end where the center is going to be until later, but then again I'm going to figure it out as I go, but I'm going to try to at least get the majority of this done in the minimum amount of operations possible, and then we can always finish it up even by hand. It is brass after all. It's not like it's freaking titanium. I don't need the feed for that. I certainly don't need carbide for this, but it happens to be set up perfect for facing because it's leveled with the center of the chuck. Maybe a little bit more. Good enough. Changing plans. I just realized I don't want to be chucking on a thread. So what I'm going to do is I'm going to turn down this end that I just spotted. We'll chuck that. Then we'll flip it around and just redo that operation. Because again, I don't want to be chucking on this. It's not going to be true. It can't be repeatable at all if I take it in and out of the chuck and yada, yada, yada. This ain't exactly the right high speed for it, but it's all I got loaded right now. I don't feel like centering another one. Like I said, it's not kryptonite. Whoops. Need feed. That kind of bites. I'm going to go ahead and change over tools after all. That kind of sucks. Well, that's actually not too terrible. I'll go with that. And I got this out quite a ways because I know I'm going to need to reach in there. I'm going to have to do a classic reach around on it and get it in between that dead center and the end, close to the end as I can. This is not necessarily optimum, but I think it'll work. It's 3/8 tool material instead of the quad 1/4 inch I've run before, so let's see how that works. No, that's not bad. Better finish, actually really nice finish. It's pushing the material a little bit, but I'm not going to worry about that too much. That's close enough. It's going to give me some flat surface there to you know, to get a grip in the chuck, and it's not going to necessarily skew it because of the threads being, you know, foot threads have a hard on. So basically I just don't want to have to deal with that. All right, flip her around. Do over. Yeah, so it runs pretty good, so now we'll get the center in. All right, well, I only have limited clearance here where I can get back with the carriage, but what I'm going to do is just start to whittle this down, and I don't know, we'll get it at least cleaned all the way up, you know, even better than this. And then I think I'll run a drill through it, and then we'll start whittling it down even more and more, because I think if I whittle it down to size, and then I shoot a drill through it, I'm going to have a lot more problems with it wanting to wander, even when it's up in the chuck. And I can't really tighten it that tight if it's so thin-walled. So I think I'd rather just turn it down a little bit to get it somewhat trued, and then we'll shoot a drill through it for the entire length of it. That'll be the inside, you know, through hole. Yeah, I got to get down past the those threads there, because what's happening is just getting a break off on the edge of it, because the thing is a formed, you know, it's a formed thread, it's not cut, so you know it's going to kind of splinter like that when you get down in there, because it's a good sharp high-speed steel tool. So yeah, try it again. Yeah, see, that's a lot better when you're getting really close to the bottom edge of it, because again, those are not cut threads. They're Chinesium form threads, and so you know, down inside there, it's, you know, it's basically rougher than the surface of the moon. So what we have to do at that point is just get down below it, and we're almost there. I want to see what it is, though, diameter-wise. If I can figure out, here it is. If I can figure out what I did with my calipers, laying in the chips. Nice. So I'm at about 184 right now. Now this is the outside, I was going to say major diameter like it's a thread. The outside diameter of this is about 130. I don't think I'm going to get down all the way to that you know, point. Again, I have put 125, you know, 1/8, 0.125, you know, this Imperial, of course, in carburetors before, and it's worked really well. And that's essentially what this is, just a little bit bigger than that. But what I might do is take it down as close as I can before I figure that it's going to collapse when I try to drill it, or at least clean up the threads. And then once I get the inside hole done, I can start whittling it down and see how it behaves and reacts at that point. But what I'm going to have to do, though, is, because I can't get this all, because it's not long enough, what I need to do is I need to whittle it down to where I'm comfortable with, flip it around, and then match that, you know, just in a separate operation, you know, because I don't want any heavy cuts at any particular point of it when I get to the point where it is thinned out. You see what I'm saying? What that is for shits and giggles. Come on now. 165-ish. Good enough for what we're doing right now, at least. Strangely satisfying. I had to fix the tailstock lock. See this guy right there, because it fell off a couple days ago and I've been too lazy to fix it. And I'm like, well, if I don't have that, the center is most definitely gonna move, and I can't have that happen. So then, of course, something else gives me trouble, and then something else, and so that's an hour gone. No, I'm kidding. All right, let's just bring this up. I don't need to support it for this. Got it chucked up pretty good, I hope. What I don't want it to do is a Dave Matthews Band imitation of Crash Into Me, so I'm going as much as close as I can. 160. That was 130. I think we'll leave it there for now because we want to drill it. And so it worked out to put a center in both sides of it for now, and I'm going to go ahead and just kind of, I don't know, put it like that's good enough. Now, as far as a drill goes, size, drill bit size, you know, we're just going to imitate, I should say match up the existing ones that's in there. So, there's a numbered drill bit set, which is kind of nice for this kind of thing because it has all sorts of little sizes. So, we'll take the good size here and kind of just figure out what's close to it. And I'm actually going to probably go a little smaller. I mean, this thing doesn't have to be a huge hole. It's not like it's flowing under pressure or anything. So size is about, in my set, a number 25. No, wait a minute. Number, yeah. Well, this says number 41. I'm sorry, I thought it said number 1. So 41. I'm going to go way down to this 47, I think. Just, you know, it doesn't need to be. Maybe, I don't know. Maybe something a little longer. Doesn't have to be that big. Let's do 46. It's a little bit of a longer bit. Then we'll take that and shove it through. Theoretically, I guess it could just about be any size because, you know, as long as it flows the fuel out the carb and not into the engine, when and if you have a problem with that, then that's the whole thing you got to consider. Is when it, you know, one of these things are set up essentially to, again, I said it before, the if you have a failure of your fuel cock or a failure of your float valve without this, and a lot of machines don't have them, which I kind of wish they would. If the intake valve happened to be open, then good night Irene, because you're going to fill the crankcase up with fuel, and you know these things end up sitting for a while. This carburetor was completely crap when I got it, as far as the insides go, and I just didn't notice this, unfortunately, because there really isn't any way to test that until you actually put fuel into the carb. I mean, you can pressurize it and then test it, but you know it happens so infrequently that the damn things fail that I didn't bother doing it. So shame on me, I guess. Disconnect the feed again. It makes too much damn noise. We don't want to push this because it'll wander. You just let it eat on its own. Whoop. See? And then that happens. That's, folks, is what you don't do. Yeah, well, we gotta let that go a little too far. Chips didn't clear, and so now we have got to fix it, which is easy. Boom. It happens. Let's get serious now. You know, this is not a precision hole, so I'm going to see basically how far that is if I do this. So it was about up to where the shank starts, so I'm just going to turn her around and finish her up. I mean, I could push it and just keep clearing it, but, you know, the bottom line is the flutes are there for a reason in a drill, you know, to clear it, so why not use them? Just be getting close to breaking through. Okay. Ooh, that's hotter than a $3 pistol. All right, we'll do an accounting now. What we got on a count that I want to. So here's our two pieces. Now the length of this is going to be that as far as the protrusion outside or above the float bowl from the bottom of the float bowl upwards, because it broke right at that bottom edge. So this is kind of nice. You got a good reference. Whatever extra length is actually the press part. All right, so once I get that point, I'll figure out how much I want to press it in and make sure that when I do press it in, this is the amount that's sticking out from there to there. What I have to do now is figure out what I want to turn this down to for a press fit into whatever drill bit that I choose to drill that out in the bottom of the float bowl. Now, previously, when I did this, I did it a long time ago on my buddy Wayne's KZ1000, that kind of dealer race bike thingy. He had broken standoffs in there. I don't remember what drill bit size I used, but I just used the 1/8 tubing, and I found a drill, I guess that was, I don't know, it cut perfectly just a few thousandths below or smaller than that. I pressed it in. So I can do it a little bit more accurately now by drilling it and then simply turning this to match that hole. And you know, I can do that on the fly. I'm only doing one carb, so I can drill it and then start turning this end down, the press fit end, even if that's a little bit smaller than the main body. And I'll kind of explain that here in a second, what this needs to be at the top. And then figure it out, arrange it for a press fit by turning down that diameter. So I'm going to figure that out. Now remember, this is 130 thousandths, or a little over an eighth. So I have to drill it out bigger than that because the remaining material in the carb body is going to come out when I drill it. I mean, that copper, or that brass rather, is not going to stay in there. So we're going to pull out the drill bits again. You can't see. There we go. I don't remember what these numbers correlate into, but what we'll do is we'll just pull a couple out here and then start measuring. So what I normally do anyway. So that's 138 right there. And that's a number 14, looks like. And the numbers, it's kind of like a wire gauge. The numbers go up, the drill goes small. That's 132. Now, I don't want to drill this out to a size that I need to obviously make that down to, and then all of a sudden realize I've drilled it either A, too big, or B, turned it down too low. So I want to do this only once. I think this is going to be too close to the original size, but I'm going to think about it. I might end up doing this next one. What was that, number 28, which is 138. So if this is 130, which it is, 129, 130, 220, 221, whatever works. So we're talking about, you know, 8 or 9 thousandths, so 4.5 thousandths on the side to take out, which is pretty much not much. So I think I'm going to go with this one. This one just kind of turns me on a little bit more. All right, since I'm using a dead center, what I'm going to do is, I already lubricated that. I'm not going to turn this down to the final diameter here because this is going to flare this a little bit. There's no doubt about it, being it's brass. And so what I'll bring it down to is, you know, if this works, as close as I can to, well, not as close as I can do it. I mean, I'll bring it down to maybe 5 thousandths above that. So 138, about 142 I'll bring it down to, maybe that's 4 thousandths. And then the reason why is the actions of clamping in the chuck even may obscure or distort it a little bit. And what I want to do is I want to just skim cut that in. Actually, I need to bring it down bigger because this needs to be bigger than a 138 because of the fact that it's probably going to drill bigger and I need to press fit it. So let's go with, I'll go to about 146. We're at 158. So maybe another 10 thousandths off of this and we'll leave it there because then I have plenty to work with. And then what I need to do is I need to drill out that float bowl, the proper depth, and then probably come back to this and finish it out. But at least I can get both sides down to that dimension, kind of a nominal starting dimension, or I should say a dimension that is ultimately going to be nominal. That's 158. So let's bring it down to 138. Let's do 148. Let's do 10 thousandths. Yeah, 150, good enough, close enough. All right. rather be big than small. My old man used to say, don't take off too much, or don't cut too much, because I forgot my putting on tool today. It was always funny. At least I thought it was. Now we definitely do not need to go hog wild here on clamping this thing in. Again, it's not freaking titanium. It's not going to the moon. So what we'll do is we'll just, whoops, I locked that prematurely. I hate it when I'm premature. Oops. I don't have any Waze oil. I ran out completely probably months ago, but I just put a little 3-in-1 light oil on there. It'll be good enough. I'm gonna make sure that I know what this is. Yeah, see, 160. So I'm gonna go 10. Could be tapering though, bowing out because of even a little bit of tool pressure, which it is, of course. A couple thousandths. No biggie though. Just do a skosh more, maybe even a spring cutlet. Yeah, pretty close. 152. All right, so now what we need to do is we need to go over to the drill press and take this drill bit, and then we'll try to get that fixtured somewhat, and then drill it out. Okay, for this operation, I'm going to use the Grizzly drill press. I got that number 42 bit in here, and it's kind of hard. You know, I probably should show you that first so you see what I'm talking about. There's the offending broken off part. What I'm going to do is I'm going to pick a center up using that drill bit, this number 42 here, which is about that size, and then just clamp it down. Now what I've done here is I got the thing trammed in best I can. This is not super precision, obviously. This vise is about as precise as cutting a taper with a butter knife, but you know, the bottom line is what I can do here is get it close, center this up on that bit, then we'll clamp it down with a couple of those, you know, welding clamps, the big clamps, spring clamp, like, you know, lock, what do they call them? Shit, these guys. Vice grip, that's it. And then we'll run a bit down in there. I don't know, I have to kind of visualize that. I won't be able to have you see that, I don't think, because I don't have a good way to put the phone here to do that, but what we'll do is we'll get you as best as we can. Table's locked already. I'm just going to get this down in there and kind of let it go where it wants. We'll check it once more again once I get it clamped a little bit here. Not a lot of tool pressure with a drill bit that size, you know, especially going into brass and aluminium. Well, I think that's going to be as close as we're going to get it. I'm not 100% sure how deep to go with this. Like I said, I'm going to have to eye this in as I go. All right, so here goes nothing. Yeah, I'm going to go with that. I have this, you probably saw I had this jacked up on the other side because, you know, you have to make a couple of assumptions. When you do something like this, you have to assume that the front face is fairly square with that hole, in other words, perpendicular to it. And this bottom edge, that is. Now the bottom edge here and there is a little different, but like I said, I ran an indicator across it, just sliding it across the table, and it seemed to be pretty flat, within 10-15 thousandths, which is fine for us. So let's take a look at the inside. See, that looks pretty good. We can work with that. What is that, about 1/8 of an inch deep, maybe just under? And that's plenty of, you know, purchase for pressing another brass tube in. So now it's time to finish it up. Wanted to show you the one caveat we have here. If you see down below those, that float, you see there's that metal piece with 4 holes and a center hole. The overflow tube goes through that center hole right there. Now, I'll tell you what that is. That's a baffle. It's essentially to keep fuel from splashing, because it is an ATV after all. and going up and leaking out the overflow, and then somebody thinks that they got an overflowing carb. So it's a baffle. Now, what some of the older motorcycles did to mitigate that was they would roll over the top of the tube itself, this tube, and so they would make the very tippy top of the tube very small. And so it would do the same thing. It would allow fuel to go down en masse. In other words, if it was overflowing that or coming above the level of that tube. But in this case, since it's just the same opening, they decided to use that little spot right there in the center as a baffle. And so splashing fuel is less likely to do that. So, but if the fuel level goes up, 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 then it's going to go through those little holes and around the tube itself and then down through the tube and signaling an overflow. So this is another thing we have to keep in mind. It's not too critical because I can always turn the end down to make it fit into there, the distal end or the top end of it. But, I'm not going to worry about that right now. But I wanted to show you what else we're dealing with here on this. Again, the length we already know because the other tube broke off at the bottom of the float bowl, so we'll just do that plus a little bit, and I'll measure the depth of that hole best I can. I'll try to calculate it out when we finish off the length and then press it in. Now these are going to cut big, as you know, especially in a drill press. If it was a milling machine with a milling bit or something, I don't know, it might be better. But so I took another drill out of that numbered drill set, a little bit bigger, and it fits snugly in there. Measured that up, and it's right at 141 and a half, 141 thousandths and a half a thousand. So now I pretty much know what that hole is at. Even with, I can feel the edge. Even with a small part like this with very little stick out and some support, we're talking some tool pressure that can make this thing decide to push away a little bit in the center, and it can actually have a taper to it. But it's not too terribly important for us on this one. Maybe a half a thousandth below the other one. It was just scuffing it. 145. Look at that. Bada bing, bada boom. All right, so we definitely have some wiggle room there because 141 and a half. So we got to do it about 143 maybe. This is pretty forgiving on a press fit as far as the diameter goes. What's not forgiving is the fact that you got to push it even in a linear fashion, and this is thin and it's brass. So I remember when I did the 4 on that KZ, I ended up scrapping one because I didn't have enough of a clearance, and when I pressed it in, it buckled, and I had to make another one. So I don't have another one of these brass bolts, so we got to be extra careful about that. But yeah, I can feel a little flare at the end here. I was talking about that before. So that's another reason why we want to just keep it really close here, and then we'll just skim the end that we want to push. Try loosening it. I want to try to push in there and press it in so you can actually see that. Just it's so soft, But we're getting there. Well, let's see for shits and giggles whether or not it fits in here. I'm not really sure if it matters at this point, but yeah, it definitely fits in there. As long as I got it pretty straight, it'll clear that because naturally this float bowl has, it registers with these holes here. So this way and that way, it has really no wiggle room. But we can turn that end down a little bit to make it a little bit more clearance as probably the last operation. Second to last or something. So I'm going to leave it this diameter now, and then what we'll do is we have to work now to the total length that we need because pretty much we don't need it this long. I mean, long is good most of the time, but in this case, it ain't. All right, I made another change. Reason why was the hole must have been bigger than I thought it was. And I test fitted it at that, I thought it was like 4 or 5 thousandths big, and it actually started to go in. So I put it in the drill press again and went to the next drill size lower after, truing it all up to the center of the drill chuck as much as I could. And then drill it down even deeper. There's plenty of meat down in there. So it's a full 1/4 inch in depth, quarter. And what that does is kind of give me a starter spot, and I think it'll be enough press fit to do what we need to do. I mean, you can't have like, it's really more of an interference. You can't have a press fit on it too much because, you know, you're pushing the copper, I mean, or brass, whatever it is. And, you know, it doesn't have a whole lot of strength, especially when it's got a hole in it. There's only one thing I know that's strong when it's got a hole in it and it's stiff. So I got it marked. It's going to be 1.650 is the total length. And we'll gently part it off here. Really no way you can use like epoxy or anything in this. I don't care what it is. The gasoline is going to get to it eventually, and it really just has to be a dry press fit. So it'll start, and then it gets real tight when it gets down to that smaller part there. So I think we should be okay to try it, you know, when we get to that point. So really what I want to do now is I'm going to put it back in, and I'm just going to knock the upper diameter down a little bit, you know, where it goes through this hole, just to make sure we got enough clearance, and then we'll be ready to push it in, which ain't going to take much. I think that's going to give us plenty of clearance into that that little area. That area needs to go up into a little baffle area I was describing before. You know what I do with this when I've done these before, and again I've only done them one time, is I actually just use the drill press to push them in. Drill press is the, you know, my particular drill press, the Grizzly, is quite apt for this. So I got it started because, you know, as I said, I screwed up and I got it a little bit big. But let's close the jaws up, and then what we'll do is we'll just push it in. I got this clamped in pretty good. It's just going to go on its own. Felt pretty good actually. Whoops. Didn't mean to punch you like that. That's what it looks like. And I hope I did it right because it ain't coming out. You can see that's, and it felt good. It was pretty stiff going in. There's a joke there somewhere. So this is how we're going to test it. We're going to use the pressure tester that I use for, you know, the carburetor floats and stuff. We'll just hook it up and block this off and see if it holds pressure. That's how I diagnosed this originally. I was wondering why I was blowing through, and I just put the pressure tester on, closed it off here, put a little soapy water in there, and it was all around the bottom. So that's how we'll do it here. We got her hooked up to the pressure tester. I'm just going to block this off. I have the bag part down just out of view, camera view. Stage left. Now there's sometimes a little settling on that because the thing stretches out. So you got to let it sit for a little bit till it kind of normalizes. Well, that's why I like to use it though, because that blood pressure cuff is an accumulator, but you know, it does kind of want to find its own little spot for a while when you first pressurize it, so you can't freak out if the thing all of a sudden starts to take a nosedive. It's just the Velcro expanding and you know, that sort of thing. But you see, I'm just around 4 psi, maybe it's just under. This is killing my finger. Ow. Let me try that again. Wow, that hurts. So yeah, before it would just go, you know, just bubble out of there. All right, so that's a success, but we are not done yet. We have to make sure that the float bowl will go on without it either bottoming out, which would be bad, but not, you know, not completely unusable, because I could always just, you know, grind off a little bit, and also that it fits through that hole. If this is square enough, X and Y, you know, this way, you know, pretty much perpendicular to that mating surface, then we're golden. So let's go ahead and check that. Okay, the carburetor, as Terrell would say, our float bowl. I'm not gonna worry about the gasket right now. And moment of truth. Oh, look at that. Now, when I first put this back together, full disclosure, I was having a hard time getting this back in. Something was stopping it. And I'm like, why is this being stopped? And I figured it was that tube, and I wasn't just lining it up properly. But I just didn't notice it. Now, I know I didn't do this. This was like this when I took it off. There's also evidence that this carb had been gone into, and the customer actually provided me with a carb rebuild kit. So he either went into it and looked at it and said screw it and put it back together or something. I don't know. Either way, that's golden. So what else was I going to check? There was something else, wasn't there? Oh yeah, there's one other thing that we have to do. And on a lot of these ATV carburetors, this little thing looks like an upside down umbrella. And what it does is it fits over your standoff here for your main jet and your emulsion tube. And that little cutout goes toward where this, excuse me, where this tube has to go. And that cutout is a clearance for this. So it needs to fit. You can kind of look right down there. And if it doesn't, then all we're going to do is take the Dremel and grind that out a little bit. But I'm thinking it might fit, yes. So we're good. Now, what the purpose of this for is kind of like what that baffle does, but in reverse. It actually keeps the fuel down by the main jet when you're bouncing around because, you know, this is an ATV. It's a quad sport. This thing's jumping around more than the first time with your girlfriend after the prom. I mean, this thing is absolutely just sloshing fuel around inside the float bowl. So basically what you want to do is make sure this is in, because it helps to keep that fuel in that spot right down there in the bottom of the carburetor float bowl, the lowest part. And then it tends to not allow the fuel to be sloshed around out of the range, I should say, of this main jet. So that's really what that's for. So that's got to be in. And of course we do have good clearance on that. Yeah. So anyway, yeah, that's it. Now, I'm not going to really charge the customer anything for this. This is kind of more like a fun project, and I'm waiting on some other parts anyway, so I don't have a nickel holding up a dime here. So I'm just going to tell them I did it, put it in the service ticket, and tell them I saved a float bowl. I did price out the price of a carburetor, because it's a pretty simple little carburetor, brand new, which is available, versus the labor of just doing a rebuild. I think Cyclopedia Pro, which I subscribe to now, shows it like 1.6 hours for a carb rebuild once it's out. So basically, even if I did basically flat rate on that, it really didn't take me that long to do this as far as the cleaning and stuff goes. Ultrasonic, blow it out, clean it up. I did put brand new jets in it. A lot of times it's worthless to try to clean a pilot jet on something that was sitting for the last century, because you can never get the damn things clean. Same thing with the mains. And so it's cheap enough just to replace them. But I just didn't know about this until just now, and I wanted to show you how I handle it. That's it, folks. I guess there's nothing else to say except this. Don't just repair, restore. Catch you on the next one.